Hello and good day. So what we're going to do today is about permutations. So it's the question goes as such: given an array norms of distinct integers, which we are going to return all the possible permutations, and we can return the answer in any order. So, for example, we have numbers that are for numbers 1 to 3. We're going to have the outputs of 1 to 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1. If it's 0 1, in the case of example, it's going to be 0 1 and 1 0. So it's more of like a simple idea of permutations. So we are going to write a function, a Python function, to be able to um, express and solve this problem. So what we understand in here is that it's about how far can we go um, in our permutations of, for example, if we are going to use 1 now, how far can we go towards 1 before we now move towards 2? And then we move deeper into the getting of our values. So there's an element of backtracking and also the elements of depth first search. So we go as deeply as possible to get all the values we can get in a specific area. So for example, if it is 1 now, we're going to go 1 2 3 and 1 3 2. We exhaust 1, and when we finish 1, we go towards 2 and then exhaust the values for when it begins with 2 till we reach a dead end. Then we move away from them and go into the number 3, as the case will be. So, for example, if it is A, B, C, D now, we're going to exhaust A and the permutations between B, C, and D, and then we move to B, and then exhaust all the permutations within that B. Then move to C, and exhaust it. So that is the depth. We are going to go depth first, and then after that, we backtrack and go to B, and then go deeper. And when we finish B, we backtrack and go to C. So it's a combination of depth first search and backtracking. But we're going to write the Python code to be able to like express these ideas we have, right? In this. So what we have here now is that the numbers is 1, 2, and 3. And our outputs, let me just get it from the code, from the what we have in the question. So this is our output as opposed to this, right? So let me just comment all of them out now. So we are going to have our as per our inputs numbers 1 to 3 and get these outputs. So how are we going to do it? You write the function, the permute function that takes in the numbers. But first of all, we are going to sort the numbers. So if it is no longer, if it's not sorted initially, it has to be sorted, right? And then we have a list that we take in all our values. So we are going to eventually return this list. So inside this function, we have a function inside it, the depth first search function that takes in an array and then a path. So here now, once you have finished going into the depths of the array and exhausted it, the array will be now empty. And if it is empty now, which means we have all our values in the path. So we are going to write an if statement. If the array is now empty, if not array, we are going to append what we've already gotten from our path into rest. If not, which means there are still values in the array, it continues going through the loop of the array, which is for I in range of the length of the array. Now check if I is greater than 0. So for example, if I is now 1, the first position, compare and see that array I, if it is equal to the previous version of the index. So if I is 1 now, check if array 1 is equal to array 0. If it is equal to that, which means you just have to continue. So it's not unique. So you have to continue. Right. Else no, this is going to be if this is this, we're going to continue. But there's no else statement actually. So once if this condition does not fulfill, right, it just continues with our for loop, which in this case we are going to have a recursion in the calling of this depth first search function. But in this case now, we are going to have in our array till this position, say I, then we are going to skip I, right? And then continue with array I plus 1, till the very end of it. Then our path is going to be the original value of the path plus the array I, right? So this depth first search and this recursion makes sure that we exhaust for each version of, for each index of the array till we exhaust it to the end, and then we backtrack it. So for example, if it is 1, 2, 3, we are going to exhaust 1 till we reach the dead end, and then we backtrack and go back to 2. And once we finish 2, we backtrack and go back to 3. So we're going to call this function depth first search. And for our array is going to be numbers, and then our path is going to be empty. And it's going to return our rest list. So we run this and have our numbers equals to 1, 2, 3. And then your computation that takes in numbers and see what is going to give us our value. So it gave us exactly what we were expecting. So 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So it's correct. So we're going to delete this and then put it in the Leetcode and see what it's going to give us. It is going to pass the test and the submission. So this will be the Leetcode. So we have numbers source, and then here we have this depth first search. If not array, here's that append for I, simply editing the code. Then this, and then returns this. And then we read pass all the conditions for all the cases, case 1, case 2, and case 3. So let's try the submission, see it's going to go. It went. So it's actually even good. It's 94.17% of persons. They made the submission. The memory is also good, 11.72. So it passed the conditions for that. So this is just the solution to the Leetcode question of permutations.